And good afternoon, CJ Stevens. You are number one. You know what that means. You get to do the audio and video report to help the technical director. Good morning. And it is a beautiful morning, too. Nice to see you guys. All the tech seems to be working. I shouldn't say that, right? Mr. Blodgett, Jello. I'm going with lemon Jello. It's just how I roll. I'm all about the acetic acid. Citric acid. I'm sorry. Bob Labs is here. All rise. Be seated. Nice to see you, sir. We were talking about things, weren't we? 3D printing. And I have 3D printing stuff to talk about today. Maybe not the flavor that you were talking about, but similar. I can touch examples of both flavors of 3D printing right here. Audio and video good. Thank you, sir. Yeah, I didn't check the lag today, but it's not looking bad. So as you're checking in here, yeah, we still are. Let's see what happened there. As you're checking in, I'll tell you we had an IT disaster Friday, and that was no fun at all. Mr. Morley is here. Welcome aboard, sir. Nice to see you. So, on Fridays, I try to get into the shop, and nobody was here in the house, and I decided to update my router. It had a software update available, so I did that, and that was a bad idea. So everything broke. It was a bad update. Something happened. It wasn't good. So I spent literally all of Friday battling this IT problem. It sucked. But we recovered from it. We learned from it. And I'll fill you in on some of what I learned. But it was real challenging. Let's see. We got our viewers are ramping up still. I'll let you guys get all sorted. Let's see. So what are you guys up to today? First of all, I got to give you the weather report in southern New Hampshire. It's 28 degrees with light snow. We have light snow. There were not quite 5 inches on the ground. It was between 4 and 5 inches on the ground, and we're getting more right now. Not much. So give me your weather check-ins. Let's see what's going on around the country. I'm a little concerned. I thought I saw something in the chat. Oh, Mr. Morley is in the shop building the spherometer. Nice. I really look forward to getting to that project. I've been just slammed. I haven't been able to do it. Cool. What are you using for an indicator on your spherometer? There's a guy on YouTube, and somebody will probably remember his name. He is a telescope guy. CJ Stevens reports 55 and yucky in East Tennessee. Yeah, Bob Labs is trying to get his first layer problems resolved. We'll fix this. That is the hardest thing in 3D printing, is getting a hold of the control. We're going to be talking about that today, of that first layer. And once you get that, it's cake. Mr. Blodgett reports 36 degrees in Oregon, raining, but that's a nice change from the ice and snow in the last few days. In other words, raining normal in Oregon. Excellent. 57 in Dallas from Mr. Morley. And K-Bonk reports 45 in Philadelphia. You acronymed me. Surfacing, sidewalk, surfacing, education day. It's 45 in Philadelphia. That's what's important. Well, cool. Yeah, it's colder up here, and we're keeping our snow from the last storm. And we're supposed to get, depending on who you believe, between 2 and 4 more inches in the next couple of days. We will see what happens. So, welcome. Happy Sunday. So let me open up here by saying a big thank you to Robin Renzetti and Tom Lipton. Last week was glorious. We had a really good... Oh, SolidWorks. Gotcha. Mr. Morley is using a Millimess, a Mar Millimess off eBay. Excellent. 50 millionths. Nice shirt. Thank you very much. I have a couple of them. Bob says it's sunny and 43 in the Chicago. So thanks again to Robin and Tom last week. Was just super. And we went 2 hours. What a shocker. And it was magnificent. And you'll laugh when I tell you this, but I only remember pieces of it because I was so busy with the technical direction of making sure that all worked. It was like a blur. So I have to go back and I have to watch the 2 hours to reabsorb all that information. But I have put some of that into play this week in the shop, and I will relate the story. Chris is here. He hates YouTube shorts. Listen, I don't care if they wear jeans. It doesn't matter to me. It was a good show, absolutely. And those guys are terrific. So I did implement a lot of what Robin and Tom taught about lapping this week. And Robin made a comment. I think he did it in last week's live. He made a comment that he saw my random live, my Instagram random live, which was like 40 minutes, in which I did the initial lapping on my lapping plates. And he said, "What were you doing for 40 minutes?" Basically he said 40 minutes I was out of control. So he was right. And I should have, well, you only learn by making mistakes. So I made a mistake. So what happened was I went past the initial lap in probably by a half an hour. And I ended up with my working lap, which is nominally on the bottom, getting a pretty nice curve to it. And that became evident when I started observing the fringe patterns that I was getting under my optical flat. And by setting up my optical flat and monochromatic light source station in the shop, it wasn't in the shop, it was up here in the lab, and tightening the loop between lapping and cleaning and measuring and lapping and cleaning and measuring, I finally started to really understand what was going on. And I want to share some of that with you guys today. I think we'll do that first, just to pick up where we left off. So let's see. I think I have some pictures to show. Let me bring up the pictures. Yeah, you'll have to forgive me. This one is not rotate. Well, I could rotate it real quick here. No, I can't. So you're just going to have to live with it. So here is the tray sitting on my bench. This is down in the shop, and you can see the working lap on the right, conditioning lap on the left. So this is sort of my setup. So what I started doing is I started lapping. Let's see. Lapping my blocks. Now you'll notice this looks pretty good. That's because I accidentally got it good before I started messing around. And then I started messing around. And right around, oh, actually, that was probably the end. That was the end game. Let's go backwards a little bit. Here we go. Okay, so you can see some curves here. Oh, one thing Robin taught me, and I want to just amplify this, is that when you have a fringe pattern where the fringes are tight, okay, they're close together, that means you have a big wedge. You put your optical flat down, and you have a big air wedge, and you can manipulate the optical flat to have a smaller air wedge, or even a like totally parallel air wedge, and the fringes get fatter. And Robin's point to me was, if you do that, you actually have better visual resolution of what's going on. So you'll see sometimes I'll have a close fringing pattern. Now they're fatter, but they're also curved. So here's where I started like observing some screw ups. Paul Morley asks, the lingering question I had regarding Robin saying straight strokes, is that for all parts that you're lapping, both round and square? Question mark. But for conditioning, you always condition it in circular motion. Not necessarily. Let me jump off here and answer that question. If you'll go back to the discussion of telescope mirrors from Adam Balogh, the course he took on telescope mirrors, they were teaching them to lap in a W pattern, okay? That's not circular motion. I've been conditioning in a circular motion. We'll talk about that in the future. So Robin doesn't like circular motion at all, and he was talking about straight, and that correlates to what Adam was talking about, Adam Balogh. So I think that's a religious argument, and we can get into it. There's some good. I could see some good reasons to not like the circular motion, but we'll get back to that. So as you can see in the photo, I'm starting to get curves. Well, that's because I started screwing something up, which I'm going to explain in a minute. Is that called tension? I don't know. Here is another shot. Now, this is not just a little bit of curvature. If you look closely, you'll see a change in the curve, and it kind of recurves near the end. There's a hint there. Here's some more curves and more curves. Okay, this is what I was talking about, that Robin said if you can manipulate your optical flat so that the bands become fat and fewer, and you get higher resolution, because each band is 1/2 a wavelength, and a wavelength is 500 and something nanometers. So it's like 250 nanometers per from black band to black band in this picture. Yeah, there's some more curvies. I posted some of this stuff. Anyway, we started. This was kind of the end game here, and we started getting some very good results in the laps. But here's what I learned. Okay, I'm going to show you a picture. I'm going to boot up my graphics operating system. Let's see. I have a couple of graphics prepared for you today. So, if you have you put your optical flat on your work, and what you do is you take your Sharpie marker and you tap the optical flat on one side, and you tap the optical flat on the other side. The side which, when you tap it, the fringes get tighter is the contact point side. Okay, the side that you tap it and the fringes get wider, in other words, it's getting more parallel, That's the fat side of the air wedge. We want to identify where the contact point is. So you tap it over here, you tap it over here. Over here, they squeeze together. That's your contact point. Now you just visualize. Look at this trick. Okay? You just visualize that this is the surface of a table and this is your work sitting on the surface of the table. So it looks like this. You're done. You have a convex shape. Same thing. You tap here, you tap here. If this is the side where the fringes get tighter, you just visualize that this is the surface of a table, okay? And you have a concave part. Isn't that cool? So once the loop was tight, right, in footsteps, and once I started figuring this out quickly, things clicked and it started making sense. And of course, what we want is straight lines and uniform spacing. Now, if you look at that photo that's hanging there, those lines are not quite straight. So we're not quite done there. That is not quite flat. Let's see. Yeah, there he is. Hi, Adam. Did you hear me talking about you? Yes, there's all sorts of stuff going on. I started truly understanding what I was looking at, and that was the important thing. So as we started improving, this is kind of where I left it. By the way, that little black corner is just the edge of the optical flat. Thanks, Paul. Yeah, once I got that, it was like, okay, I can now move quickly, right? I can now tighten up my feedback loop. So that's all you need to know. Once you've got that, it's like you're done. You don't need charts. You don't need you don't need anything. So what I figured out was, in that fateful 40 minutes of lapping, or whatever the heck it was, I had very significantly created a convex surface on my working lap. I made a mirror, right? I made a telescope mirror. And now when I go to lap my work, and I started to really start to visualize what was going on, I'm like, oh, my work is concave. So I'm like, Robin's right. I went way too far. So now I had to go the other way. So remember, Adam, we were talking about this. I took my laps, I turned them upside down, and I started lapping upside down. You can do this because the laps are identical, right? They're at same size, same weight, same everything. So I just went bloop, turned them upside down, and now the conditioning lap was on the bottom and the working lap was on the top. Yeah, so you're asking a good question, Adam. The end result looks pretty darn good, like a quarter wave flatness. Yeah, that one was a quarter wave-ish, maybe less. No, that's less than a quarter wave. I think that's like an eighth of a wave of flatness. But the second question you ask is very incisive. What are you trying to achieve? I have no idea. I'm just learning. So I'm trying to just get control. And the purpose of the exercise was, can I control this? Can I make the curves go one way and then make the curves go the other way? And I started to see good results because I had to lap upside down, right? I had to lap upside down until my overly convex working lap started coming back to flat. And then what I really want to do is I want to go past it a little bit and prove to myself that I went past it, and then I want to bring it back. So to answer your question, Adam, that's the purpose of this exercise. Do I have control over this? You know, I previously told the story of teaching, spins and gliders, or being taught spins and gliders, and also teaching spins and gliders, where we would use the rudder. We'd be right on the edge of stall in a bank, and we'd use the rudder to kick into a spin, kick out of a spin, kick into the spin, and kick out of the spin. And once you had control and you knew that you were kicking in, kicking out, it's like you were dancing on the edge. You had control. So that's what I'm trying to do. I'm trying to get to flat, go past flat, bring it back, and understand that. So I started seeing that this week. But I have to say that the mistake I made in the beginning was a whole lot of work to get back. Now, I'm not done yet. So I'm still working on it. But that's what's going on. So that's the lapping story from this week. And I was pretty happy with the direction things were going in. I'll tell you another thing. You have to be ready for the physical standing there and lapping. It does not go quickly. So that was the lapping story. It is coming back to flat slowly, and we'll keep posting photos. So you'll watch that on Instagram. Also, during the live last week, Robin says maybe 6 drops of the slurry was the right amount. I needed a little more. If I use 6 drops of slurry, I ended up getting some serious ringing of the blocks. And if I used 10 drops of slurry, I had what felt like good performance, and it didn't end up ringing. So, Adam says people spend entire careers learning how to achieve better than 1/8 wave flatness. Why not shoot for hitting a certain tolerance quickly and reliably? You're a good teacher, sir. I'm not quite done. Let me put it a different way. As soon as I'm done with, yes, I have control of the situation, then I will accept a tolerance and go for some dimensional accuracy. So that's kind of where I'm at. I'm still learning how to ride the bicycle. So I also started experimenting with how much of the slurry I needed, and it definitely was less than I was using previously, but it was a little more than Robin was suggesting. So my number is about 10 drops on a 6-inch lap. And that was working pretty good. And then I ran out of time. So we had a very good experience. And more to come on that. But yes, the goal, just to wrap up the whole lapping story here, the goal is to be able to make a gauge block like surface, and we're getting a lot closer. So I know Adam and I talked about making a tool maker's block that has a surface like a gauge block, a ringable surface. Now, I didn't bring them upstairs, but I have my little 1-inch discs they're ringing like epoxy. They're fantastic. In fact, it's better than I deserve. But they're also it's only over 1 inch. So I've achieved gauge block ringing over 1 inch. Now, this picture you saw is a 1, 2, 3 block. So it's 2 by 3 inches. That's a lot more area. I admit it, and we're getting there. So that was the lapping story. Let's see. I'm going to keep it a little light today. I was going to get into something that I think I'm going to leave for another week. It's just too big a topic. I was so exhausted after last week. It was amazing. So we'll keep this one a little light. And guys, feel free to keep jamming questions or comments into the chat, you're going to drive what we do today. Let's see. We did that. Check. We did that. Check. Hey, did you see on your Instagram feed, if you follow Kaiser, the compressor guys, they used my video again, which I'm happy to have them do that, and they tagged me on it. And the video was a comparison that I did between my old Quincy compressor and my new Kaiser in terms of sound level. And it was like 82 dBA versus 60, basically it's like 63 dBA. It was almost 20 dB. And they used it again on their feed. So that was kind of fun. So thank you, Kaiser. We love you. We still love you. We love the yellow. And I'm due for my annual maintenance, which is amazing because it seemed like it was like last week that we did annual maintenance on the Kaiser. Let's see. Kevin asks, did you get a count of how many people showed up last week? You know, I didn't prepare myself with that information. I do know that the total views on that video are around over 300, maybe 400 total views of that video. That includes live and after the fact. So it's, as far as machining topic videos, it's the highest performer. Anytime I do a video on 3D printing, it seems to get a lot more traffic because of 3D printing. Oh yes, okay. I did see that, Paul. Paul says, when you get the time, did you see the Dual Master Gauge toolbox workstation that Steve Summers came into the possession of? Yeah, that was gorgeous. That was really nice. And I guess what was missing in there was a box of gauge blocks. I think that was all that was missing. But otherwise, it was pretty cool. And yes, I had a little bit of precision envy. But that was pretty neat. Another huge success this week was in 3D printing land. So most of you know that I make a product for grinder coolant called the NOS. This is the NOS. There we go. This is the NOS 3, which means it's 3 inches wide. This has the lock line. I believe it's called the half-inch class lock line connection. And I make these by resin printing because it's the only way to make them. If the light's just right, you can see the nozzles. There you go. Have angled holes, so it focuses. More information at noz.gg, noz.gg. But anyway, these are problematic to make because these capillaries, these holes, are very hard to get to come out right without clogging. So this week I had to solve that problem, mostly because I had orders to fill. And I'm happy to say we solved that problem. I'll show you a picture of... There's a picture of a batch of the 3-inch noses just finished and hanging from the build plate in the printer. So what I started doing is using compressed air and breaking up the wash cycle so that I would wash it. It gets washed in isopropyl alcohol. And then we would blow compressed air in the holes and then continue the wash and then do it again. And then we started getting very nice results. So the noses are coming out beautifully, and we're getting more customers for the 3-inch noses for the large grinders. So the very first, here's a fun fact. The very first 3-inch nos was made for John Grimsmo for their Okamoto that's used to make all their knife blades. And that's still in use. And now more of these are flying out the door. So we have the 2-inch NOS for smaller grinders, like 8-inch class wheels. And then the 3-inch is for 12 to 14-inch class wheels or bigger. And it gives a little more working room. So very exciting developments there. The process reliability is starting to go right through the roof. I'm very pleased with it. The second improvement in the department of resin printing department had to do with the mixing of the resin. So it's the dirty little secret that we don't talk about. Formlabs mentions it. You know, if you haven't printed in a while, you know, shake your resin cartridge 6 times. Yeah. So I put in the nutating mixer, and a mechanical means of mixing the resin. And now that is a standard part of my process. So if we haven't printed that day, the resin cartridge goes into the nutating mixer. It gets turned on while you go and get other stuff set up, so that by the time you start printing, you have a well-mixed cartridge. That was a palpable change. Everything started working much nicer after that. So between those two changes, the use of compressed air in the washing cycle and the improved mixing of the resin, big wins happening. And there's some other little process changes that I made that just basically implements those two things, but awesome quality we're getting out of it. So here's hashtag not sponsored. Formlabs, we love you. This is out of my Form 3 Plus. Bob Lab says, did you model the NOS in Fusion? By the way, there's no E in NOS. It's just N-O-Z. Yes, it was actually designed in Fusion, 100%. So we go from Fusion and we hit the utilities button, and then we hit the generate a 3D print button. And then you the way I do it, if you uncheck the box that says send it to a utility, it will make an STL file, and you can put that wherever you want. I usually do that because I like to store the STL file. And then I bring that STL file into Formlabs software called Preform. And Preform is getting better and better. So in Preform is where you bring the model in, you orient it, you build the supports, you select your resin and all that kind of stuff, and you hit the go button, and it will send it to the printer. And if your printer is primed, that's a term of art, it will just start printing. So I'm up here, the basement is 2 levels down, and frequently I will get a model going and just hit print, and it will start downstairs, and off it goes. So good question. So yeah, we solved the capillary problem, and we solved the mixing problem, and that's the story. Okay, Bob says no .3MF. There in the Formlabs world, they have a .form file, and that's, as you are imagining, the whole process. So your entire project is in that file. And I do store those also in a folder for the product. And that's what I keep on hand. So I get an order that comes in for NOSes. I go to Preform, and I bring the form file in that has that product in it, and I get it going, and I hit print. So the profit margin, we're in business here. The profit margin on the NOSes is not that big. If you do a really thorough analysis, you may think it's way too small, but it's forcing me to get that process sorted out, and it's getting better and better. So that's the story on the NOSes, and I'm very happy about it. I actually have the next generation of NOSes in design I'm going to be making some improvements. So let's see what else is going on. If anybody has any NAS questions or 3D printing questions, ask them now. If I could jump over to resin printing, or what do we call that? FDM, fusion deposition. Let's just call it filament printing. Bob Labs and I have been talking about the issue of that first layer. And one of the biggest problems is especially for a beginner, is getting that first layer right. And PLA is easier, I think, but it still needs to be done right. And I wish I had that picture ready that you sent me. If you get the Z height too low on your first layer, you can start plowing the nearby layers, and I think that is what was going on yours, Bob. If you get your first layer Z height too high, then you get like a toothpaste tube. It squeezes out onto the plate, but it's not sticking to the plate. There's no squish. So there's this magic spot between those two. And one of the best things you can do, especially if you have gray hair, is put the magnifiers on and get down there. Get your nose right on the bed, and look at the shape of that first layer, and it will start telling you what's going on. If you can't see that shape, you're not going to get it. So you're going to have to just back up. So Bob sent me a picture of a first layer that he was having trouble with, and my diagnosis was, I think you're too low. So I suggested he come up a little bit. Now, another thing that you need to do in the 3D printing with filament is keep that nozzle clean. And you'll hear people talk about putting silicone socks on the nozzle, and that's all cool, but just wipe the damn thing. So as soon as it comes up to temperature, or is almost up to temperature, I take, and this is in my video called Reliable PETG on the Prusa. I take a pair of tweezers, I wrap a Kim wipe around it, and I go under there and I wipe the I wipe the schnozzle, right? And then as I do it, and the Kim wipe gets dirty, I unroll it a little bit, and then I wipe up more, and then I unroll it a little bit, and I wipe more. And I do that to every printer before it starts a print, and it really keeps the burnt crap from coming off the nozzle, or from building up on the nozzle and then dropping, bird droppings on your print. So that's an important thing to do. So you'll get there. You're on your way. I wish you were down the street. I'd come over and help you with that. But that's the thing you need to be doing. Okay, in other news, I did my very first, let's see if I can get this picture up for you. I did my very first rotary laser engraving this week. I purchased the rotary attachment tool for my Epilog laser. Now this wasn't a frivolous purchase. This has been on the list for a long time. And what this does is it allows you to do laser engraving on a cylinder, and it drives the cylinder. Now there's two flavors of rotary engravers for the Epilog, well, in general, but for the Epilog laser, they actually have two models. One of them looks to us machinists as a lathe. It looks like a lathe. So it's a 3-jaw chuck being driven by the laser. The other one is called a rim drive, and that's what this one it's over here somewhere. That's what this one is. It's called a rim drive rotary attachment. So you can take, for example, Chris, I'm looking at you. You could take something like this and put it on there, and it will rotate it. Look at that. It will rotate it and do an engraving. And I'm here to show you my very first. I'm so proud. Let's see if I have a picture of this thing. There it is. This was on Instagram. my very first rotary engraving, which, as you can tell, is our Laser Shark. And this is just a scrap of aluminum that I had kicking around the shop. It happens to have blue paint on it. Doesn't mean anything. And also, don't get confused. There are some, if you're using a CO2 laser, there are some sprays that you put on a surface so that your CO2, like a metal surface, so your CO2 laser can make a mark, because a CO2 laser cannot make a mark on a metal surface. This is a fiber laser, and that is actually etched in the aluminum. That's not just paint removal. That is both paint removal and etched in the aluminum. So there it is, my very first rotary engraving. It wasn't too hard to get it up and running. It's like bringing up any CNC machine. You kind of scratch your head and beat your head against the wall for a while until you figure out what's going on. But it came out really well. So we will be doing some fun stuff. And Chris dared me to get this thing further engraved. We'll just say that, further engraved. And I will do it for next week, I promise. But I just ran out of time this morning in preparation for this video. So there we go. We're rotary laser equipped. And if you go on Instagram, you will see a little video of that running. Let's see. And then a buddy of mine sends me this. Warning label. We may steal that artwork. I don't know where it came from, and put it on something. So anyway, if you have any laser questions, I'm happy to answer them. The difference between a CO2 laser and a so-called fiber laser, I hate the terms, is the wavelength. CO2 laser is about a 10 micron wavelength, and a fiber laser is about a 1 micron wavelength. So the way to think about this is organics like wood, like oils, like plastics, have big molecules, and they interact most with a big wavelength, okay? Whereas metal, like aluminum or stainless steel or whatever metal you're going to engrave, the very small molecules, they interact best with a small wavelength. So the fiber laser, the word fiber implies fiber optics, which is how it works, but it doesn't tell you anything. It's about a 1 micron wavelength. And the CO2 laser, which is the most common laser out there, is about a 10 micron wavelength. So when you look at lasers, you know, after all the dust settles, just ask the question, what is the wavelength? And that's the important number. Okay. So that's wavelengths. I promised to give you an update on my Ford F-150 Lightning, and I'm happy to report that I have put my 1,000 miles on it, and I love it. I really do. Let's do the positives first. It is magnificently comfortable. It is very smooth. You do not miss a piston engine at all. It is very quiet, very smooth, and the interior is very comfortable. The electronics, the huge screen in the Lariat puts a big map up and does all sorts of driving controls and stuff. In addition to doing Apple AirPlay or the equivalent Android, it's all built in. Works great. The sound system, I hear people complaining about it. It sounds great. It's a Bang & Olufsen, blah blah blah. So the overall impression is it's really quite nice. It's my first truck, so that's a whole separate topic, and I won't bore you with it. I think we talked a little bit about it last week. So in the first 1,000 miles, you would imagine that my biggest problem was charging. So K-Bonk asks if I've always been a Ford guy, and my last vehicle was a Ford Flex. That was actually my first Ford. Before that, I was, you know, we had Hondas. We had two different Hondas, a Civic and an Odyssey van. Lots of Volkswagens. We went through about 3 or 4 Golfs, more or less. My original vehicle, brand new vehicle, was a Golf, and then another Golf, and then a hand-me-down Golf, and so we went through Golfs. So no, the Flex was my first Ford. I understand Forddom, not the Fordham tool, but Fordosity, put it that way. And I know what to expect as far as service and quality and all that kind of stuff. I found a dealership I love, so that is very important. But anyway, back to the vehicle. Charging has been a non-issue. I can charge at home. I'm only using the small charger, so it's not a fast charge, and that's fine. In fact, I got to go downstairs and plug it in. We have the whatchamacallit, the big charger, the Pro charger. I'll show you a picture of the Pro charger installation getting ready here. So there we go. So the Pro charger is about that big, right? And this is outside my garage. In fact, if you look right behind me, you can see the vertical machining center, the Sharp. That's the door the Sharp is behind. So that's where the Pro charger is going to go. And I've marked it out. I found my studs. I'm waiting on my electrician to reemerge, but I'm going to start mounting it and drilling holes and starting to get ready for my electrician. The Pro charger will deliver about 80 amps. So that's about, I think, 20 miles an hour. So overnight, you basically can do a full charge on the battery. It's funny to rate a charger in miles per hour, but that's what it is. It's miles per hour. So this is about 20 miles an hour. And the small charger is about 1/3 of that. So it's about 7 miles an hour. And if you run it on 220 volts, if you run it at 150 volts, it's about 3 miles an hour or 2 miles an hour. It's really slow. So even without that, and with the education in charging stations, like I'm using the Electrify America charging stations that are a couple miles away. I'm pretty comfortable with things, and the onboard information is good for telling me where chargers are. And now that I've used them, and Ford gives you some free charging, so it's pretty comfortable. And it's like going to a gas station. And everybody, I hear this. Well, what do you, aren't you worried about running out of charge, and you're not near a charging station? Well, do you ever worry about that in your car? I bet you have like 4 gas stations you use 90% of the time. It's kind of going to be the same thing. So it's not a big worry. So I've been very happy. The first 1,000 miles have been outstanding, and I'll report back I guess at 5,000 miles or so. But now on to the negatives. You knew the negatives were coming. Their software, not the user interface software, which has a few minor issues, but their communication software, their networking software, their downloading software does not make me happy. It does not inspire confidence. So that's the big negative. It's the only negative so far. So we'll see. I got an email this week that they have an update available for my truck, and that I will be getting it. So I will report back to tell you whether or not that came in cleanly. I've been checking repeatedly for an update. Yeah, there aren't many negatives. That's the only negative. But from an engineering point of view, guess what I was prepared to talk about today. You probably know what that means. I'm not going to dwell on this because I promised I'd leave it for another day. But that's the only thing that is a little painful, is that updating process. And I'm going to leave it at that because I don't want to just sit here and whine. The truck drives great, charges, comfortable, wonderful, exceeds expectations in that regard. I'll talk to you at 5,000 miles. Okay, so that's the Ford report. I think we talked about, and I can't emphasize that the comfort is really nice. The environmentals are very good. It's electric truck, so when you turn the heat on, you're thinking about, oh my, I'm turning my electrons into heat. But really, it's just fine. So there you go. So at this point, we're going to open the floor to any questions, any topic. Go, put it in the chat, and we'll, if we plan this just right, we will run out of avgas and go into a steady glide and make it back to the airport at the top of the hour. So if you have any questions or topics, put it in the chat, and we'll jump on it. And I want to welcome the new viewers, because I know we got a bunch of new viewers as a side effect of the Robin Renzetti and Tom Lipton session last week. Welcome aboard. We're going to try to do guests on the order of once a month, if not twice a month. And then at other times, you just got me. I am so sorry. But there you go. Checking my list. Let's see if I have any other photos to show you from the week in review. I posted. I posted all these. Here's a. No, I think you guys have seen all these. Robert Simpson asks, how is the heating effect on the range? So one of the things you get, you could punch this up on the screen. You could say, show me how my energy is being used on this trip. And you can go back to previous trips also. And it will show you. When I take my kiddo to high school, it's a short trip. I preheat the car. I sit in the car with him, and we schmooze for a little bit before he goes into the school. That trip is like 50% environmental energy and 50% driving energy. If I get in the car and I drive to, like I might drive down to see my mom, that trip, the environmentals will be maybe 10%. And of course, in the winter, here's something that's interesting. When we think about internal combustion engines, the colder and drier the air, the better, right? But this vehicle does not like to be cold, and the aerodynamics don't favor the cold. The air gets denser, and that's not good for aerodynamics. And a battery is a chemical process, and cold does not help chemical processes. So the cold is a very significant impact. Now, I haven't owned the vehicle for a full cycle, for a whole trip around the sun yet. But I can tell you that it's pretty obvious when it gets really cold. Like it was almost single digits, and the range shrunk. But, the vehicle knows and the app knows, and it says, yeah, you got 157 miles in the tank, whereas the day before I had 175 miles in the tank and I didn't use it. So the temperature is a definite impact. Flood coolant. Okay, yeah, we could talk more about flood coolant. I will take homework. So look at, Paul, go over to nos.gg. I have some coolant information for the grinder, and you are talking about your grinder. So coolant on the grinder. I'm a big fan of full flood coolant on the grinder. So I have taken that as homework. Kevin says, did you solve antenna attachment issues? I forgot to talk about that. It's all aluminum. So you know, if you were used to taking a mag mount antenna and sticking it on the vehicle, you know, temporarily, that ain't happening. It's aluminum. So the answer is no. I have not solved antenna attachment issues, although I am pretty attached to certain antennas. However, it does, of course, have the hitch, and it's got all sorts of attachment points in the bed and around the bed and tie downs and stuff. I don't know if you know this, but I actually have a complete satellite tracking setup, which goes on my trailer. That setup can go on the truck now, so we may be looking at that. Sleeping Saloon says, how do you inspect/evaluate your charged laps with a spherometer, etc., without lapping the spherometer, or do you? So you ask a wise question. And again, this is one of those things that Robin said 50 times, and I didn't understand it. Now I understand it. Yeah. K-Bonk says, VHB for the win. I am a big VHB. In fact, I'm about to reorder a big roll of VHB. The thing I learned from Robin, and I now understand after putting my initial hours in, is that you don't look at the lap. You never look at the lap. You look at the work. Because if you lap the work, and then you measure the work, and then you make your adjustments, you go around the feedback loop, right? This is, you're pulling me in. I was trying to stay away from it. That's a feedback loop, okay? I was going to talk about feedback loops. Are you looking at the right thing? If you care about your lap shape and not care about your work shape, you're making a big error, okay? So I finally figured that out from what Robin was talking about, and that's what he was talking about. So no, I don't even measure the laps. I look at the work, and the work is informing me that what I need to do. And that's what I learned. So now, having said all that, I would have no problem going in with a test indicator and very lightly sweeping my lap. With, again, remember pressure. You need pressure to actually remove metal. I wouldn't have a problem with that. However, I also have no motivation to do it. I'm starting to understand from what the work is telling me what I need to do, and I just follow those instructions. I have no desire to measure the lap. I did. I thought that was important, and I was real curious, and I wanted to do that. I don't care. The work is telling me what I need to know. Does that make sense? I hope it didn't sound smug, but that's kind of how it goes. Biased lap. Yes. So I don't know if this is what you mean. Okay. I think you and I are on the same wavelength, Mr. Sanchez. Your lap is not going to be flat when it's making flat work. I don't want to sound authoritative on this because I'm a student. I just want to remind you, I am simply a student. But this is the conclusion I've come to. When your lap is producing perfect flatness on your parts, that lap is not flat. Because there's other effects that you've compensated for without knowing you've compensated for. And I don't understand that completely, but things like, the edges getting different a different amount of lapping than the center, if you only look at your part, you will automatically adjust to get the curvature you need to make flat parts. I hope that makes sense, but I have no desire to measure the lap anymore. I probably will, but I don't think it's important. And Adam, if I said anything wrong, please smack me. I would definitely welcome your feedback. Feedback. We're back to feedback. Okay, we've hit the top of the hour. You guys are awesome. I don't want to go longer than we have to. This was a lot of fun. This was pretty relaxing compared to last week. I was a stress ball, but it came out good. So with that, I promise to come back with coolant. Thank you, Sleeping Saloon. I will come back with coolant on the grinder information, and we will make that at least a segment real soon. Okay? The short version is Qualichem 250 3%. Yeah, I know what you're saying, Paul. Paul says the spherometer is only used... Oh, I see. Paul is talking to Sleeping Saloon. The spherometer is only used as a comparator to compare the main lap with the conditioning lap. So what I'm saying, Paul, and I don't know if I thought this a couple of weeks ago, but I think it now, you don't need to. I think you could do it from an educational point of view, but from a practical point of view, I don't think you need to do it. Okay, CJ, take care. Have an awesome week. Everybody have an awesome week, and we'll see you same bat time, same bat channel. Tell your friends, tell your neighbors. We'll see you next Sunday. Take care.